Hello, everyone. My name is Connor Friedman, and today I'm going to be presenting you my project and how I used a machine learning model to help me beat a boss within Dark Souls 3. Let's picture me below. Thank you. Now, Dark Souls 3 is, in my opinion, one of the best games ever made. And truthfully, I want as many people as possible to experience Dark Souls 3. So, over the years, I've convinced a ton of my friends to try to play the game. And unfortunately, not many of them have actually finished it due to its difficulty. While this is sad, I really want these players to fully experience the game because it's much more than just difficult gameplay. It's a beautiful cinematic experience with a pretty rich story that's extremely nuanced. And if they're not able to get past the difficulties the game gives you, they'll simply never experience this. Now, my project is inspired by my dad, who I first introduced him to this game. He was super into it. But he eventually reached a point where the difficulty of the game was something he could no longer defeat without hours and hours of gameplay. But instead of simply installing a cheat that allowed him to pass them, he handed the controller off to me because he just wanted to see what the fight looked like playing out. And that really inspired me to make my project. So what's the issue I'm trying to solve? So Dark Souls 3 is an extremely difficult game, and not just for old people like my dad. It's so difficult that most people who buy the game are not actually able to beat it because of how hard it is. In fact, only 30% over its 10-year lifespan, only 37% of the people who've actually bought the game beat it, which is insane because games in this genre can get up to 60, 70, or even 80% completion rate. And unfortunately, there's no way to artificially decrease the difficulty of Dark Souls 3, meaning you either adapt to its extremely hard gameplay or you quit playing altogether. Surprisingly, despite the size and popularity of Dark Souls 3, and it essentially popularizing the Souls genre altogether, the only way to autonomously defeat a boss is by downloading a mod that simply kills it without any effort. I want to create something flexible that can give players that simply want to learn how to play the game but are struggling with it an in game mentor, or players who are simply done with an extremely difficult boss, a way out that still allows them to experience the cinematic-esque fights the game offers. Now, to do this, I created a machine learning model that analyzes the game and responds with what it believes to be the most optimal move, beating the boss without the player having to do anything. Now, this, as I stated before, this gives the player both an in-game mentor that allows them to train themselves, or a simple solution to a fight they're struggling with. This allows people unable to beat the game, unable to keep up with the game's difficulty due to disability, or those too busy to dump most of their free time into the game, to either learn how to beat a boss without having to ram their head at it over and over again, or experience the fight for themselves, even if they deemed it too difficult or tedious to complete on their own. There were three main steps to my project that occupied most of my time. Firstly, I created a game loop that runs alongside the model. This loop extracts data, teleports the player to the entrance of the fight, and reruns its loop after detecting a win or loss. Second, I created a training dataset through a script that records the inputs made by the player, in-game events occurring at the time of the inputs, and in-game data, such as player HP, boss HP, etc. This is all done with the help of SoulsGym, an extension of OpenAI's Gymnasium tool. Finally, using a simple neural network, I created a machine learning model that reads in live data from the fight and makes the most optimal, or what it believes to be the most optimal, move at that moment, essentially beating the boss all on its own. Now, what I mean by the game loop is a loop that plays during each run, whether that be training or testing. So, to start off, the game teleports the player to the entrance of the fighting arena. The player enters and locks their camera onto the boss, which allows them, to focus their camera. During the training phase of my project, this is when a new JSON file was created in order to track information regarding the run. Now, onto the second part of mine. This mostly depends on which phase of the project you're in. During the training phase, the player fights the boss manually as a script in the background records information about the fight to a JSON file, including your inputs. However, during the testing phase of my project, the machine learning model runs here instead, predicting the most optimal move to use at that given moment. Finally, the loop terminates if either the boss's HP drops to 0 or the player's HP drops to 0. After terminating the loop, my script will begin to collect image data in order to detect whether or not the player has respawned, as running the loop before the character is able to move crashes the game. Additionally, during the training phase of my project, this is when new information will cease to be written into the JSON file, with the file itself being saved into a folder containing the rest of the data. Next up is the data collection aspect of my project, which surprisingly turned out to be its most difficult part. Now, OpenAI's Gymnasium is a Python library that provides a standard interface for reinforcement learning environments, allowing agents, such as our player, to interact, learn, and to be evaluated consistently across a lot of different tasks. Now, Gymnasium can be used for a multitude of different games, online environments, etc. But it comes on its own, it's really hard to train with a specific game in a specific environment. Here's where Soul Gym comes in. Created by PhD students from the University of Munich, Soul Gym is an extension of OpenAI's Gymnasium that's specifically designed to replicate environments found within Souls-like games, such as Elden Ring and Dark Souls 3. In my project, I used Souls Gym to replicate the arena of the boss I'm fighting, a guy named Udix Gundyr. While Solution is fantastic, it's only one piece of the larger puzzle I need to make the training dataset. The second thing I need is a script that can physically run each of these processes and ensures that everything is working properly. So, the first part of the script reads in a file containing the current run number, updates it by one, and creates a new JSON file for the new data to be stored in. For example, currently I've made about 75 different uh, I've had 75 different runs in Dark Souls 3 that I've recorded and used to train my model. If I were to run this again, it would read in the number 75, update it to 76, record that number within the new JSON dataset, then save that 76 to the run number file. Now, after that's done, and the player starts to fight the boss, for every new input the player makes, so when they press a key down on their keyboard or press a button on their Xbox controller, the following information is recorded. Game data, which holds information such as the player's HP, the boss's HP, my character's endurance, which, as you see from the gameplay, it's a green bar that allows the player to make moves. Current event, which tracks the animation of the boss, allowing my player to respond to its attacks, and key pressed. Key pressed, which should be obvious given the name, and reward, which tracks how well the model is doing. Now, in order to record every input, I needed to make sure that data collection used a key map associated with a move in the game. I did this to ensure that the game doesn't react through both my script and the interaction within the game, potentially screwing up the game data by not capturing all of the events caused by me pressing a key down. Essentially, how this works is I press a key corresponding to an action in my code, the code records it, then the code tells my player to press that key in game, acting as a sort of middleman of sorts to ensure that my data is being processed properly. And finally, all of this information is stored in a dictionary. And once this training loop is, and once the game loop I talked about before is complete, it exports this to a JSON file and saved it on my computer. After playing Dark Souls 3, and specifically that Udix Gundyr fight, about 75 times, which took up about 4 hours of my life, some would even consider that to be five, I was then able to move on to the machine learning aspect of my project. And surprisingly, this was the easiest part. So, after I completed the training dataset for my model, I then was able to train a rather simple neural network off of the data I collected. What this neural network does is it extracts data from the game at a current moment, calculates what move I would use in that moment it extracted the data, then outputs that move. So, What I ended up doing with my script is I would it was extremely similar to the one I used in my training data set. But rather than recording what data I had made, it inputs the data it extracts to the neural network, then uses the move the neural network thinks would be, best in that moment. And it's able to do this about every third of a second. But there's something interesting about this process I want to note, and it has to do with how I, made the training data set. So, while my model does use a simple neural network, this network isn't trained to be the most optimal, as it's not really how the training process works. My model is what's known as an imitation learning model, meaning that it's not trained to use the best possible move at a current moment. It's simply trained to replicate what I would have done at that moment. Now, why does this work? So, not to toot my own horn or anything, but I'm pretty good at the game. So across hundreds of training runs, or potential training runs, I'd say about 90% of the actions I made in game were considered to be correct, or at least had a positive benefit in that boss fight. Meaning, when the neural network attempts to replicate the gameplay I made during my training process, it's probably going to be the best move possible for that current situation. Now, enough talking. Here's a video of my project actually working. So, unfortunately, in the end, my character wasn't able to beat Udex on its own. However, it's clear that he was able to properly read and respond to Udex's attacks, which is what I was trying to do with my model. It's clear that with more time and more training data, my model will eventually be able to beat Udex on its own. But due to how long the training data set took me to make, I just wasn't able to complete it in the time frame. But I do hope to have it be able to beat Udex in the future. Additionally, I plan to continue my work on this model by expanding it to other bosses in the game, especially, more notorious bosses, because this is considered to be one of the easier ones. And on top of that, I plan on additionally implementing my model in Elden Ring due to the similarity of their gameplay. I had a ton of fun with my project. It really taught me a lot about how data is processed in these games and how to make models that process this data and interact with the game itself. As I really enjoyed my time with this project. Thank you for listening, everybody. Do you have any questions?